Hi, my name is Dale Maley. I'd like to tell you about a recent discovery I made that might save you a lot of headaches and aggravation. Now, a little background on this video. I've been building hand-cranked wood models for over 10 years. I've built over 50 different kinds of these models. And in all those models, I've always used Johnson's wax to lubricate the moving elements. Typically, I would take my fingers and get a scoop out of the can, then rub it into shafts, the bearings for the shafts, gears, anything that was rotating and had friction. Now, I did not buff out the wax because most cases it's impossible to even access it to buff it out. In fact, I usually use the idea the more the better. Anyway, once I lubricated the parts, I would assemble the model, and I usually found the friction was dramatically reduced, which means there's less torque required for kids to hand crank my models. So here's the last model I just built. You can see the hand crank on the left. That runs a set of 2 gears, and I use Johnson's wax typically to lubricate the gear shafts and the bore holes they go into. Over on the right is a set of peg gears. I'd actually rub it onto the pegs of the gears. I'd also put it on their shafts and their bores as well. So about a year ago, in March of 2025, I built the model shown here, which is kind of an intricate model. It actually is hand cranked, and it has 2 different planetary gear sets. And I went to grab my old can of Johnson's wax, but I found out it was just about empty. So I thought, well, that's not a problem. I'll just go buy a new can. That's when I was shocked to discover that Johnson's discontinued their Johnson's wax at the end of 2021. Wow. I tried to buy an old can on eBay, and I was shocked to see people selling partial cans of Johnson wax for $100. So I went back to my local Fairbury, Illinois Ace Hardware, looked on the shelf, and I thought, hey, paste wax is paste wax. Just buy another brand. So I bought the Trewax shown here. So back in March of 2021 on this planetary gear model, I switched over to the Trewax from Johnson's wax. And I worked on it for several weeks, and I just could not get the friction level reduced enough to make it easy to hand crank. I even modified the wood parts in the model. I tried every trick in the book. I actually just gave up, and I put the model on the shelf around April of 2025. So about 8 months after I just set the model on the shelf, I drug it back out, and I decided, hey, I'm going to reduce that cranking force somehow on that. But before I tore it apart, I went ahead and cranked it, and I was totally shocked because there was almost no torque required to crank it. It was super easy. And basically the model had healed itself. No, I'm an engineer, and I don't believe in miracles like that, so it really bothered me. Why in the world did that model heal itself? So this month, January of 2026, I decided to build a new model featuring an Archimedes style wood screw to lift up the marbles. And like all my other 50 past models, I liberally applied Trewax instead of Johnson's wax to all the points that needed lubricating. Now the first day or so, the hand crank torque level seemed okay, but then I let it sit for a week or 2, and then I tried it out again. Anyway, I was very surprised that all of a sudden the hand torque went very high, way too high, all by itself. So I removed the screw box from my hand crank model, and all that was left on the model was the hand crank and then about half of the peg gear with a couple bearings. Cranked that, had no friction at all, which is what I expected. However, when I went to the screw box, I tried to rotate that wood screw by hand. I was really surprised at the high level of friction it took to turn it. So I disassembled the screw box, which is a wood screw surrounded by wood sides and one plastic side. And what I found was the bearing joints at the top and bottom, they were sticky to the touch, to my fingers. The Trewax had not dried, and it turned very sticky. I also found it sticky on the interface between the bottom of the screw and the bearing plate, which is a piece of wood that it rubbed on. So I took my Dremel, which has a 1/2-inch size drum sander, and removed that Trewax from all the bores, or 3/4 inch diameter bores. Reassembled the model back up with no wax, and voila, no friction whatsoever. At this point it dawned on me the reason my planetary gear model had healed itself was that the Trewax I used finally dried in the areas that had little air exposure, like the bearings. So let me first say I'm a mechanical engineer, not a chemist. Anyway, I developed a theory that Johnson's wax must be chemically different than the Trewax. And the Johnson's wax must have dried quicker, especially in the areas that have little air exposure like the shaft and the bearings. Trewax, on the other hand, in those areas turned sticky, which created the high friction and high cranking torque. After so many months, I don't really know, because it was 6 or 8 months later, the Trewax finally did dry out and was not sticky anymore, and that's why my model, planetary gear set model, healed itself. I did search the internet, and I did find that it said Trewax must be buffed out to a thin layer for it to dry and not be sticky. So my theory is that it has something to do with the chemistry difference between Johnson's wax and Trewax for my application. So since Trewax doesn't work on my projects, what else could I do? Well, I could try another paste wax. Minwax makes one. Or I could use common paraffin, which is also called canning wax or candle wax. I already buy that by the bars, and I already rubbed screws on it, metal screws, as a lubrication before I screw them into wood. And then I could rub the bar on shafts and the accessible areas. Now where I have like 3/4 inch bores where shafts are going in there, how do I get it inside the bore? Well, I could cut a 1/2 inch wide slice off from the bar and then literally rub it in the hole. Another option might be to melt the paraffin on a sacrificial dowel, nice and thick, and then just rub that dowel into the hole, which would transfer some of the paraffin into the hole itself. Here's a photo of my old box of paraffin. I can't remember, it either has 4 or 5 of those paraffin bars in it. Took me 40 years, and I just used that up a couple years ago, but they still sell it at grocery stores and hardware stores, either for canning or for candle making. And on the bottom one, it's kind of hard to see, but you can see where I've taken wood screws and rubbed it on the bar to transfer it over, the paraffin over to the screw. Some closing thoughts on this. I never thought that Johnson Wax discontinuing its product would cause me so many problems on my wood models I make. So I made this video so maybe other people don't waste the hours I did and the frustration levels I did in this type of moving parts application. Now Trewax may work fine as a replacement for Johnson's Wax in other different applications. I really don't know. But I do know it doesn't work in my wooden parts applications. So in summary, this video explains why you shouldn't try to use Trewax on rotating element wood models. I hope you enjoyed the video. I hope it saves you some time and grief on your projects. And please subscribe. Thank you.